In section 9.2.3, we're looking at the sum in arithmetic sequence. So if you remember from 9.1, a sum of a sequence is called a series. So the sum of an arithmetic sequence would be called an arithmetic series. So we can evaluate a finite or a partial sum arithmetic series with these formulas, which look a little intimidating, but they're not really that bad, especially if you think about how they're derived, which has gone through in more detail in your textbook. But I'll do kind of a quick how I remember this anyway. So for a simple example, I'm going to say let's find the sum of the sequence of the first 9 terms of 1 plus 2 plus 3. So this series, 5, 6, 7, 8, and 9. So to add those together, so think about how you add these together. You probably found compatible numbers, like 9 and 1 are easy to add together, they're 10. And the 8 and the 2, that's 10 also. The 7 and 3, so that's 3 10s, so that's 30. And then 6 and 4, that's 40. And then you got that extra 5 in the middle, so now that's 45. So I found that sum by thinking about my first and my last number. That sum, which is this, times half the number of numbers that I'm summing together, because I group up 2 pairs of numbers. So that's the n divided by 2. So that's not a perfect proof or anything, but that's kind of gets the idea of the proof. So you can actually view that, how to derive that formula in your textbook for this section. But I want to focus more on how to apply it. So let's look at numbers 41 to 52. We're going to find the sum of, let's see, your homework is every other odd from this section. So we'll do 42 and 48 for examples. So for number 42, I start at 0 and go to 20. Well, these sums, remember my partial sums always start at n equals 1. Remember that partial sum means the sum from n equals 1 to n. So I need that first term of 0 to 1, 5k. And then I can add the rest of them. So for the first term, I'll separate that because this formula will give me that partial sum. This guy I can get from here. And then this one I have to get on my own. So if I plug in a 0 for k, I get the sum of 0, right? 5 times 0 is 0. So that's actually 0. And then adding the partial sum from 1 to 20 of 5k. Now that 5k, that's an arithmetic series where we're adding 5 each time. So we have to decide which of these formulas will work better. Well, let's see. Do I know D? And if I don't know D, then do I know AN? Both formulas have the N, and both formulas need A1. So those I need no matter what. But D or AN, whichever one of those I can find, is going to tell me which formula to use. Let's see. I do not, well, I do know the D is 5, actually. So I could use either of these pretty easily. I'm going to use this one, though. So our N equals 20. Our A1, that's the first term, so plug in 1 for k and we get 5. And our 20th term is 5 times 20, which is 100. And now using this formula, I get that the sum from n equal to 1 to k equal to 1 to 20 of 5k equals n over 2, which is 20 over 2 times the sum of A1 plus A2. So that's 105. So that's 10 times 105. So I should separate that. 100. I'll write that as 5 plus 100. And then I get 105 times 10, which is 1,050. So I could use the other formula with that difference of 5, and that will still give me the same number. I just kind of picked a formula and went with it. So there is my sum. Okay, let's go to 48 now. So in 48, I have A1, my first number is 1. My last number is negative 75. My N, oh, that's something I don't know. And my D is negative 4. So I see my D is negative 4. I have to have N because both formulas have an N. So in order to find N, I'm going to use that formula AN equals A1 plus N minus 1 times D. And I know my last term. I need to find what is the N for that last term. So I know that AN is negative 75. I don't know what N is. A1 is 1. N minus 1 I don't know because I don't know N. And D is negative 4. So now I can solve for N. So let's see, negative 5. Simplifying this, I get on the right side, I get 1, distribute the 4, and I get minus 4n plus 4. And then adding 5, or subtracting 5 from both sides because I can combine the 1 and the 4. And then subtract 5 from both sides, I get negative 80 equals negative 4n. So divide both sides by negative 4, and I get a positive 20. So now I have n, and now I can plug it into either one of these formulas. I'm going to go with that one again. That one's a little easier to remember. So n divided by 2, let's see, n is 20. We're going to add that to our list. So n equals 20. N divided by 2 is then 10. A1 is 1. And AN is negative 75. So that is 10 times negative 74, which is negative 740. Okay, once you feel comfortable with those two examples, it's time to go look at an example from the textbook. So I'd like to open your electronic textbook and get the video for example 5 and watch that. That is on page, I do not know what page that one's on. 709. Okay, so pause this video, watch that example, and then come on back here. All right, so you saw example 5, which is like the problems from 53 to 58. So let's open number 54 to try it. Go ahead and try that one, and then come back here and see how you did. Okay, so our first 21 terms of the sequence. The sequence looks like it has a common difference of 3. So my D equals a positive 3. And my first term is a 2. And my, let's see, what else do I need? And we want the first 21 terms, so that n is going to be 21. And that is all I need for this formula. So even though I don't know what the final term is, I can use this formula now. So that gives me S of 21 equals n over 2 is 21 over 2. 2 times a1 is 2 times 2 plus n minus 1. So that's 21 minus 1 is 20. And then the d is 3. So simplifying that, I get 11.5. Oh, sorry. That's 10.5 times 4 plus 60, or 10.5 times 64. So 10 times 60 is 600, plus half of 64 is plus 40 plus 32. So that gives me 672. All right. And that wraps up section 9.2.